2.4a, the chain rule. So the chain rule is used whenever we're deriving composite functions, and composite functions are just functions made out of two functions. Here are two different ways that it is shown. I basically stick to this one on the right. So if y is f of g of x, then dy dx, the derivative of this composite function, is going to be f prime of g of x times g prime of x. This is referred to as deriving the outer function, which f is considered the outer function, and deriving the inner function. G is the inner function. And we multiply them. However, if you notice, when you derive the outer function, the inner function is still inside of it, and it remains as such. So f prime of g of x, right, you're deriving the outside part of it, but the inside part, g of x, is still going to be g of x. That doesn't change. What changes is the stuff around it. And then when you do derive g prime, when you do derive g and get g prime, that is just the derivative of g prime. Some people say the derivative of the outside times the derivative of the inside, and some people write the outer times the inner. Right? Kind of like low d high minus high d low. The d stands for deriving. So you derive the outer and you multiply by the derivative of the inner. Okay, so let's put that to use, and hopefully it'll make a little more sense. So in example 1, here we have two different composite functions. And it's sometimes really easy to tell what part is the inner function because there's parentheses or a square root, such as in these two examples. For a, 4x squared plus 1, see how it's inside the parentheses and it has an exponent? Well, the 4x squared plus 1 is going to be the inside function. And I'm going to name it u. Hopefully you've noticed that we use a lot of u and v because of the product and quotient rule. So for composite functions, we use u as well, and sometimes v, and sometimes w. We just use all of the letters we have to in order to get the job done. So 4x squared plus 1 is the inner function. Basically, and I'm just going to break this down very quickly, this is a composite function. Let's say it's composed of two functions, f of x and g of x, right? Just like I explained at the beginning. And we're going to call f the outer function, and g of x the inner function. Well, if g of x is the 4x squared plus 1, which I just labeled u, then the outer function has something to do with that exponent, 6. So f of x would have been something like this, as simple as that, x to the 6th power. But then when combined, f of g of x, when I composed a new equation or function out of these two functions, I would have ended up with x to the 6th, right? X to the 6th, but instead of using x, I would use g. So 4x squared plus 1. So that's how you get your composite function. Well, I need you to learn how to break these down. Break them apart so that you can figure out what is the inner and what is the outer. Okay, so that was just a real quick touch on composite functions. Okay, so here's u. So basically, I'm rewriting this with a u to understand, okay, u to the 6th. I'm going to treat this as my outer function. U itself is my inner function. So when I derive, so y prime is going to be the derivative of the out function, the outer function, and then I'm going to multiply that by the inner function. Remember, the outer times the inner. So the outer function, I have named or renamed that u to the 6th. So if I derive that, I get 6 times u to the 5th power. Now this is the derivative of the outside function, but notice how u is unchanged. U is still u. It has a new exponent and a number being multiplied, but u is still u. Now this is the outer, So now I need the inner, the derivative of the inside. Since I did call the inside u, we can just write du, which just means the derivative of u. It's very easy to figure out what the derivative of u is, and you can even write it wherever you like. Let's write it down here. What is the derivative of u? So if u is 4x squared plus 1, the derivative is just going to be 8x. So now that I have derived using these new symbols, right? I don't know that I want to call them variables. Technically, they're standing in for entire functions. But I've used u, um, but u never really existed. U was just a means to an end. We used u to help us get the answer. So what we're going to do now is we're going to actually plug what u is back into the equation, or the function. So 6 times u is supposed to be 4x squared plus 1, this is to the 5th power, times du. And du we already found here in the green, the derivative of u, which was 8x. And that's it. This is my derivative. The only thing I would do is 6 times 8, and then just rewrite it like that. But here's my derivative. For b, same idea. Let's see. The square root is a very good indicator of what's the inside function. 3x cubed, that's the inside function. So this is basically u to, well, the square root of u. But when we have square roots, we actually like changing them to exponents. So this is u to the 1/2 power. Now, I'm going to need the derivative of u. U is 3x cubed. So 3 times 3 is 9x, and then subtract an exponent, 9x squared. So now when I derive this, let's see, y prime equals, I need the derivative of the outer function. So this is my outer function. 1/2 u to the negative 1/2 power, because I had to subtract 1 whole from 1/2. And then times du. And now I just replace everything because u is not really part of my original function. Oh, hold on. I'm using, let's use red. Why not? So y prime is, so 1/2 times u. What was u? Oh yeah, 3x cubed to the negative 1/2 times du, which is just 9x squared. Right? The only thing here to do is rewrite. The negative 1/2 tells me that this is actually a denominator now. So 9x cubed, or sorry, not cubed, squared, 9x squared over the 1/2, there's the 2 part, and then the 3x cubed is in the square root. So 3x cubed, and voila. All right, example 2, derive h of x equals x cubed times 2x minus 5 to the 4th. So this is a product rule, okay? Product rule, and again, product rule, you have u times v prime plus v times u prime. So you need a u and a v, so this is my u, and this will be my v, all of it. But if you notice, v is a composite function, so we're going to actually have to do the product rule and the chain rule in this one example. So let's break it up. U is x cubed. You know you're going to need u prime, so that's 3x squared. Okay, v, let's do that in red. V is 2x minus 5 to the 4th. And we're going to need v prime. But see, to derive v, I'm going to need the chain rule because it is a composite function. So what we do, since I'm already using u, because this is a product rule, I'm going to add a new letter. And this letter is going to be w, right? U, v, w, alphabet. So how this works is my outer function, 2x minus 5 is the inner. The 4th power, the exponent, that's part of my outer function. So we're going to call the inside function w. And then so w to the 4th will be my outer function. From the previous examples, I know that I'm going to need the derivative of this inner function, and we're going to call it dw, right? So dw is the derivative of w. W is 2x minus 5. So derive that, and it's just 2. Okay, so v prime is composed of two functions, so I'm going to need the chain rule. So I'm going to have to derive the outside function, which is w to the fourth. So I get 4w to the third, and then I'm going to multiply that by the inner function, which is just dw. And so here is my derivative of v prime, I'm sorry, of v, which is v prime. And the only thing left to do is to actually replace it with numbers. No more of this w business. So 4 times w, which is 2x minus 5, to the third power times dw, which was over here, right? 2. So simplify the 4 and the 2, right? That's a multiplication, that's a dot, not a negative. 4 times 2 is 8, and then 2x minus 5 to the third. So there's v prime. Okay, so now I have all of my pieces. Let's see, I'm gonna highlight them. So here's u prime, and this is v, and this is v prime. So now all I gotta do is the original regular old product rule, and I have my pieces that I can just place into the function itself. I think I'm gonna have to do this lower because I'm probably not gonna have enough space. I never have enough space. So h prime of x equals, so u, that's x cubed, times v prime. So that's 8 times 2x minus 5 cubed plus v. V is 2x minus 5 to the fourth times u prime, which is 3x squared. I would just bring the scalars, the numbers that are being multiplied, right, the coefficients to the front. Any loose variables to the front, for example, the 3x squared should be in the front, and then that could stay like that. And then 8 should come to the front, and that's it. We're not going to simplify this any further, but that is the chain rule with product rule. All right, example 3. This time we have something to plug in. Oh wait, hold on a second. Oh, we're supposed to have something to plug in. I guess I made a boo-boo. Let me fix that. All right, so find g prime of 1 if g of t equals 3x minus 1 squared, quantity squared, divided by x cubed plus 3. So this is going to be a quotient rule because I'm dividing functions here. But if you pay close attention, the top function, the high function here, is a composite. Okay, so this is going to be u over v. So again, let's break it up. U is 3x minus 1 squared. I'm going to need u prime, which is the derivative of this function, but this function is a composite function. So again, w squared. So u prime is going to be 2 times w times dw. The derivative of the outer times the derivative of the inner. This right here, 3x minus 1, is what I replaced with w. So that is my inner function. The outer function involves the exponent, the squared. So that's how I get 2 times w. Now dw, let's write that down. dw is just the derivative of w. Derivative of 3x minus 1, which is just 3. Okay, so let me finish this off. So 2 times w. W was 3x minus 1 times dw, which was just 3. And basically this is just 6 times 3x minus 1. Okay, so we have u prime. We're going to need v. So v is the bottom function, x cubed plus 3. It's not composite, So no need to do any chain rule. V prime is just 3x squared. I have all my pieces once again. Let's see, let's highlight. I have V, I have V prime, I have U. U is just 3x minus 1 squared. And then U prime is going to be this right here. 6 times 3x minus 1. Okay, so let's derive. So G prime of 1. So that means I'm actually going to plug in 1. So I don't have to simplify anything, thank goodness, because quotient rule usually looks really yucky. What I'm going to do is I'm going to derive, and then I'm going to plug in 1. Okay, so G prime of 1, so it's V. So V is x cubed plus 3 times U prime, which is 6. Oh, well, I'll just write it in another parenthesis. 6 times 3x minus 1 minus, okay, so far I have V times U prime. So minus now, U, let's see, what was U? U was 3x minus 1 times V prime. So it's just 3x squared. And voila, I had space. Miracle. So that's the top part of my quotient rule. Now divide by V squared. See, V is x cubed plus 3 squared. I do apologize for my poor handwriting. I'm doing this on a tablet. So, okay, so I have my entire derivative. Normally, yes, you would simplify it some. But because I get to plug in 1, I don't really have to worry about that. Please don't simplify. There is no point in simplifying if you're just going to plug in an x and try to get an answer out of that. You might make a mistake. All right, so let's see. So for every x, we're going to get 1. So 1 cubed, that is 1 plus 3 times 6 times 3 times 1, which is 3 minus 1. All right, minus 3 times 1 is 3 again, minus 1, times 3 times 1 squared, which is just 3, divided by, and then I have 1 cubed, which is just 1, plus 3, and then that's getting squared. All right, let me go down a little. All right, let's see. 1 plus 3 is 4. 4 times 6 times 3 minus 1, which is 2. Okay, minus 3 times 1, that is, oh no, that's not times. Oops, that's a, I mean, I don't think I wrote it wrong. It just looked really small. That should be 3 minus 1. So 3 minus 1 is just 2 times 3. And then this is over, oops, that's a horrible line, times 3 over, that's better. Slanted either, but whatever. 1 plus 3 is 4, and that's squared. Alrighty then. Now there's a lot of numbers to keep track of, so you want to make sure that you didn't miss something. For example, I'm going to go back up, but not too much. Okay, so again, this was V, right, times U prime. Where's my U prime? Oh, it's right here, right? So this is all of U prime minus U, which was this, oh, see, that's not U. I totally forgot this little dude right here. Forgot my 2, my squared. Well, that makes a bit of a difference, just a little. Right, let me add my square there. 3 minus 1 is 2, but now it's 2 squared. Alright, so U, and then back to, this should be V prime. 3x squared. Okay, and then the bottom should be V, but it should be squared. X cubed plus 3. Okay. Sometimes the smallest mistakes occur, and then you get all of it wrong, and you did it right. You're like, what? So I forgot it too. Okay, back to, now that I've rechecked my work, I'm confident that I should get the right answer. Let's see, 4 times 6, that's 24. Times 2, 48. Minus 2 squared is 4. 4 times 3 is 12. Over 4 squared, which is 16. 48 minus 12 is 36 over 16. 4 goes into both of them. 36 divided by 4 is 9. 16 divided by 4 is 4. So my answer should be, so g prime of 1 is 9/4. No need to make it into a decimal, right? Perfect. All right. Next, example 4. Okay, so here we're deriving another composite function to end off our trip around composite functions using the chain rule. So break it down. If you want to try to do this on your own, it would be a really good time to just pause and try to see if you can do it on your own. All right, so to start off, I'm deriving this function and it has a square root. So a square root is a really good indicator that this stuff in here, under the square root, is my inside function. So I have the square root of u. Well, actually, let me write this down here. So I have the square root of u, which we're going to use as an exponent instead. So that's u. Now du would be the derivative of u, which is 2 times 4, and then subtract 1. There's my derivative of u. So let's derive. So u to the 1/2 power is going to be 1/2 u to the negative 1/2 power, because I have to subtract a whole, times du. So that's it. That's my derivative. U doesn't really exist, so let me plug in what u is supposed to be. So 1/2 times 2 times x to the 4th plus 5 to the negative 1/2 power times 8x cubed. And then just rewrite. For example, the negative 1/2 power means it's a square root, but as a denominator now. So 2 and the square root of 2x to the 4th plus 5. And then the 8x cubed on top. And the only thing that I could see happening here is 8 divided by 2 is 4. 4x cubed. Can't make straight lines. That's better. Oh, Narita, you got rid of the 2. Okay, so square root 2x to the 4th plus 5. And that's it. That is the chain rule. Answer the practice problems, and there will be a quiz next class on deriving functions and using the product rule and the quotient rule. The quiz does not include the chain rule, but it does include everything up to, I think it was 2.3c. I can't remember if it was C or D.